Welcome to Introduction to the Cycle Theorem with Brother Maxwell Dependable Reeves. Before we begin to elaborate on the 7 cycle theorems, do you actually know what a cycle is? A cycle refers to the set of all points that are of equal distance from a fixed or given point called the center. Let's consider this to be a cycle. If this is a cycle, it means that the distance around this cycle is what we refer to as the circumference. So the circumference refers to the distance around the circle. And the circumference is usually equal to 2 pi times r, where pi is a constant. Pi is equal to 22 over 7, or we say 3.14. And r represents the radius of the circle. The circumference is also equal to pi times d. D represents the diameter. And the diameter is a line that divides the circle into 2 equal parts. So this line is called the diameter. So if we have to draw another line from the diameter, now this line is referred to as the radius. So the radius of the circle is half the diameter. So for short, we say the radius is equal to 1 over 2 times d. So the radius of the circle is always half the diameter of the circle. Now, this part of the circle that you see referred to as a sector. So a sector is an area of the circle that touches the circumference at 2 points. So here's the area of the circles that touches the circles at exactly what? 2 points. So here's the area. So the small part of the circumference here, I see from here all the way here, it refers to as an arc. An arc, it just refers to the portion of the circumference of the circle. So an arc is a portion of the circumference of the circle. So the distance from this point to this point, we can name this point here point A, and we can name this point B. So the distance from point A to point B refers to the arc length. So the arc length is equal to the angle from here refers to theta. We can call the angle theta, we call it alpha, we call it beta, we call it any Greek or letter or symbol. So the arc length is equal to the circumference of the circle, which is 2 pi r times the angle from theta, all divided by 360 degrees. So this is how we can calculate the arc length. So to write the arc length in a geometric form, we can say arc AB. So here's an arc, and this is simple for the arc length. So now, we can also find the sector area. So the sector area, or we can say the area of the sector, is equal to the area of the circle. The area of the circle here we have pi times r square. The area of the circle pi times r square times theta all over 360. So this is the area of the sector. This is how we can calculate the area of the sector. So now, let's consider this circle again. Considering this identical circle, if we having to draw a line outside the circle, this line, it touches the circle at exactly one point on the circumference of the circle. This line refers to as a tangent line, or we say tangent. So a tangent line is a line that is drawn that touches the circle at exactly one point. And this one point here is referred to as the point of tangency. So here a tangent line, for example, we can name it M, N, and P. So we can say line MP is tangent to the circle at point N, which means point N is the one point that line MP touches the circumference of the circle at. So whenever a circle is drawn and a line touches it at exactly one point, we refer to that line as a tangent line. For example, in case we draw a line in a circle like this line here it refers to as a chord. A chord is also referred to as a secant line. It touches the circle at exactly 2 points. Whenever you have a chord in a circle, now both sides, either side of the chord refers to as a segment. We have two types of segments. We have the major segment and we have the minor segments. The major segment is always bigger or larger than the minor segments. So it means that this portion refers to as the major segment, while this portion refers to as the minor segment. And this line here drawn is a chord. So this is a chord. So when a chord is drawn, we always have two segments. We have a major segment and we have a minor segments. So now, since we are knowledgeable about some of the basic key terms that we'll be using in the circle theorems, we can now move to the 7 circle theorem. Let's get started. All right. So let us look at the first 5 circle theorems. Thereafter, we move to the next 2. Let's see the first one. 1. Angles at the center is twice the angle at the circumference. Now, the first theorem telling us that the angle that is formed at the center of the circle is 2 times the angle that formed at the circumference of the circle. Now, let's consider this. The symbol for angle is this symbol or this sign. So this symbol usually denotes angle. So here we see angle AOC. Now, the letters that last in the middle usually carries the angle. So since O is in the middle, it means O will bear the angle. So the angle as point O here is N. So angle AOC, which is the angle formed at the center of the circle, is equal to twice. Twice means 2. 2 times the parenthesis represents multiplication. 2 times the angle formed at the circumference of the circle. The angle for the circumference is angle ABC. Since B lies in the middle, it means B bears the angle. The angle at point B is M. So it's twice angle ABC. So here we see that angle AOC is represented by N. So N equal to twice means 2. And angle ABC is M. So 2 times M give us 2M. Now, for the sake of simplicity, let's do this in another form. If we were given angle M to be 35 degrees, and we are asked to find an angle M, we know that the angle formed at the circumference is twice, the angle formed at the center is twice the angle formed at the circumference of the circle. So the angle formed at the center here is N. So know that angle N here is going to us what? Or angle AOC. So angle AOC is equal to 2 times the angle for the circumference is angle ABC. So angle ABC. Replacing angle AOC to be N. So N is equal to 2 times angle ABC is 35. 35. So we can clearly see that 2 times 35 will give us 70 degrees. So it means that angle AOC, which is denoted by N, is equal to 70 degrees. 2 times 5, 10, where 0 here 1. 2 times 3, 6, but the 1 give us 7. So this is how we use it. Now, in case we are having, let's say, the value for N here to be equal to 120, and we are asked to find, let's say, Y and Y. We can also use the same theorem to determine the value for Y. So let's look here. So here, we know that the angle formed at the center is twice the angle formed at the circumference. So the angle formed at the center here now is just 20. So here we can see that 20 degree, 120 degree is equal to 2 times the angle formed at the circumference. The angle formed at the circumference here is Y, equal to 2 times Y, or 2Y. We want to find Y, we divide both sides by 2, we divide both sides by 2. So 2 cancel 2, we have Y is equal to 2 here, 1 time, 2 here we have 60 times. So Y is equal to 60 degrees. So this is another way we can use this theorem. Let's move to theorem 2. Theorem 2 tells that opposite angles in a cyclic quadrilateral add up to 180 degrees. A cyclic quadrilateral is a quadrilateral that is inscribed within a circle. So whenever we have a quadrilateral inscribed in a circle, we consider it as a cyclic quadrilateral. So opposite angles in a cyclic quadrilateral, it adds up or is summed up to 180 degrees. So let's look here. So this is a cyclic quadrilateral because each point of the quadrilateral, it touches the circumference of the circle. So here we have angle A and angle B are opposite each other. So the rules tell that opposite angles in a cyclic quadrilateral add up or sum up to 180 degrees. So we can see that angle A plus angle B will be equal to 180. So we have angle A plus angle B equal to 180, and we have angle C and angle D are also opposite angles in the cyclic quadrilateral. So they will sum up or add up to 180 degrees. So we can see that angle C plus angle D also equal to 180. Now, for the sake of simplicity, let's do it in another form. If the value for A was given to us as, let's say, 70 degrees, what will be the value for B? I know that 70 plus B should give me 180. So I know that 70 plus angle B will be equal to 180. And I know that to find B, I will transpose or send 70 across equal sign. Sending 70 across will change 70 to negative. So I will have 180 minus 70, which will give me angle P to be equal to 110 degrees. This simply tells us that 110 plus 70 give us 180. So opposite angles now have sum up to 180 degrees. So we can do the same for angle C and angle T. So let's move to the theorems. The theorem tells us that angles on the same arc at the circumference are equal. So we have angle A and angle B are formed in the same arc. So since angle A and angle B are formed from the same arc, it means that they are equal. So angle A equal to angle B, and angle C and angle D are also formed from the same arc, so they are also equal. So angle C equal to angle D. In other words, if we have 30 degree here, it means that here will also be 30 degree, because these are angles from the same arc at the circumference, so they are equal. So that move to the fourth theorem. The angle, the diameter of a circle subtends at the circumference is 90 degrees. Or in other form, we can say the angle formed from a semicircle is equal to 90 degrees. So this is the diameter of the circle. This line that divides the circle into two equal parts. So we can see that the angle formed away from the diameter, or the angle that is sustained from the diameter, is equal to 90 degrees. So this box here is represent 90 degrees. So let's move to the fifth theorem. A tangent and a radius meet at 90 degrees. A tangent line, I told you that, is a line that touches the circle at exactly one point, and that point is called the point of tangency. So we can see that the tangent line here is touching the circle at exactly one point. But we have the radius that moving from the center of the circle that touching or that is perpendicular to the tangent line. So both the radius and the tangent line, they meet at 90 degrees. So this is the fifth theorem. So let us move to our next two theorems. So let us consider our last two theorems. Let us see theorem 6. Theorem 6 is one of the most powerful circle theorems. This is my favorite theorem. It refers to as the alternate segment theorem. Now, I will tell you the easier way to identify the alternate segment theorem. In order to identify the alternate segment theorem, first and foremost, you should have an inscribed triangle, or triangle that is formed within a circle that touches the circumference of the circle. So each point of the triangle should touch the circumference of the circle. When you have an inscribed triangle, the next thing to check for is your tangent line. Or tangent line is a line that is drawn outside of the circle that touches it at exactly one point. And this one point is referred to as the point of tangency. Thereafter, you can check for a chord. A chord is a line that touches the circle at exactly 2 points. It is also referred to as a secant line. So here, when you have the three theorems, it means that the alternate segment theorem is applicable. So we have an inscribed triangle, we have a tangent line, and we have a chord. Here's a chord, here's a chord. So here we say the angle between a chord and a tangent. So what is the chord? Here is the chord. So here's the tangent line. So the angle here between the chord and the tangent is equal to the angle in the alternate segment. So what is the alternate segment? So at this point here, the alternate segment for this point is this point. If we're using the side here, at this point here, this is a tangent line here, and between the tangent line here is a chord. So between the tangent line and the chord, we have an angle. So the angle here should be equal to the angle in the alternate segment, the angle right here. So now, to make life easier for you, let me place a 50 degree here. If here is 50 degree, it means that the 50 degree should be equal to the angle in the alternate segment, because the 50 degree lies between the tangent line and the chord. So therefore, it must be equal to the angle in the alternate segment. One of the easier ways to identify the angle in the alternate segment is by moving 3 places. So there is point 1, there is point 2, there is point 3. So at the third point is the angle in the alternate segment. If we're using the side here, there is point 1, this is 0.2, this is 0.3. So if we have 50 degree here, a mean here will be 50 degree. If we have 30 degree here, a mean here will be 30 degree. So now let's do the other way around. In case we have, let's name this A, B, C, D, and we have 35 degree here, and we are asked to find angle. We are asked to find angle AEC. So angle AEC. I told you previously that the letter that lies in the middle bears the angle. So since E is in the middle here, it means E will carry the angle. So at point E, you'll have a AEC. So the angle that is here is unknown, it's angle not found. But the angle given to all here is 35. So this angle here is in the what? Alternate segment to this angle. How do we know? 1, 2, 3. This angle here lies between the tangent line and our core. So it must be equal to the angle in the alternate segment. So here is 35, and here is also what? 35. So therefore, angle AEC equal to 35. Thank you for your time. I'll see you in my next video where we'll be solving the past was question on circle theorems. Please subscribe if you like the video. I love you, but Jesus loves you most.